Good morning, Dr. in a Dungeon once again. It is Wednesday, July 10th, 2019. Happy Wednesday. I did a primer on 3D printing and basically talked about the process and of the two videos that I shot for that yesterday. One was slightly out of focus and the other the file corrupted, and so I'm going to reshoot that again today. And so what I'm going to do is I'm going to walk you through the process of making this mount, and I have talked about it a little bit before, I think. Let's see if I can get this in the focus. Where is it? I think that's fairly in focus. So anyhow, it's a GoPro mount, and it has the little nubbin out here for using in my Noga. It has got this profile here that will slide into my tripod, and then the latest addition that I did to this was, there it goes, was adding a 1/4-20 nut on the underside so that I can mount my little micro tripod and put this thing wherever I want. So I'm going to walk you through the design process of that, and hopefully it will be helpful for you. When I first started 3D printing, I found it very difficult to find all the information that I wanted. And so I'm going to try to simplify that process. I'm going to walk through the design process on SolidWorks, which is what we use here at work. I'm actually an AutoCAD guy. I learned AutoCAD way back in 1989, release 10 I believe it was. And so I've been working with SolidWorks for a couple years. Not as familiar, as competent with it as I'd like to be. So making a concerted effort to gain some more familiarity, some competence with SolidWorks. I'm able to do what I want to do. It just takes me a little longer than it should sometimes. So I'm going to walk you through the design process and all the way through to getting it ready for a 3D print, and we'll go from there. Back shortly. All right, here we are back. So again, we're going to be designing this, and I've done this a couple times, and we're just going to be designing this base part here, not the skeleton for the camera. I actually grabbed that off of Thingiverse. So things that we're going to need. Going to need some way to quasi-accurately measure. So we got here a Fowler dial indicator. I am going to be using, two different nuts. Why did that just go out of focus? There we go. Two different nuts. One is an M5, which is for the screw handle, the opposite side here, and then the 1/4-20 is the other one, which will go in here. Okay. All right, let me get you focused back in here on the screen. That looks pretty good. And so again, we use SolidWorks. Also use Inventor from time to time, AutoCAD. They're all somewhat similar, but you know, they each have their own little ways of doing things. So SolidWorks is what we use here at work at Taylor University, and as I stated earlier, I still don't have the competence with SolidWorks that I'd like to have, so I'm going to make it a concerted effort to get a little better. So we're going to start with a new part, And we'll go ahead and start with a sketch. And I'm just going to go ahead and sketch it in the front plane. Alright, and so I'm terrible with math, so I do all my math on a calculator just to make sure. So the actual bottom piece of this is 1.75 inches square, and so half of that is 0.875. So I'm just going to take and do a line and go 0.875 or thereabouts. Wait a minute. There we go. There we go. 0.875. Enter. Escape. So that's a construction line for me, and then I'm going to do a center rectangle and grab there, go there, and then I'll stretch that out to 1.75. So we're going to adjust these to 0.875. And there we go. Alright, so then I'll go ahead and exit the sketch. Features, extruded base, grab that whole thing, and then I think that is 0.375, I believe. Yep, 375. 375, enter. That's good. All right. So go back to sketch, and then go right there. All right. Actually, before I do that, let's go back to this. Let's go back. So what I want to do now is go ahead and this is a 20-degree taper right here. You can see that from the oblique angle there. And so we'll go ahead and do that. So go back to features, and we'll go here. And I don't want fillet, I want chamfer. And so pick up those bottom edges. And that should get it. Oh, nope. Up the wrong side, chamfer. There we go. There, that's what we want. Alright, so yay, that's what we want. Let's get this arranged somewhat. Go back here to this plane. Alright, now I'm going to go back into a sketch. Sketch again. Pick the plane that I want to do it in. And then I'm going to do this little platform right here. Yeah, hopefully you can see that well. Go ahead and do that. And it's 1.75 as well. So I'll do the exact same thing that I did earlier. Actually, I don't even need to do that. I can just go ahead and do the center because I already have something that I can snap to. There we go. Alright, exit sketch, features, extrude, that. And I think that's 1/4 of an inch. Yep. And go 0.125. And ta-da. Alright, so now we got that. I will come back later and I will fillet these corners to make them nice and smooth. Alright, let's go back to that. So the next thing that I'm going to draw is I'm going to draw the geometry for these three fingers that actually clamp the GoPro to this. And so the whole thing, I think, is, yeah, 3/4 of an inch, 750 thousandths. So again, I'm going to do the same thing. I'm going to go to sketch, pick the plane, go right here, and then that was 750 thousandths wide by 625 thousandths across. So let's see. Let's go here. So let me do my math again. 0.74 by 625. I got to do my math here. $375. And then 625.3125. Should work just fine. There we go. Okay, so that gives me my centered geometry for my fingers, and so now each of the fingers is 1/8 of an inch, 0.125, and then the gaps in between are 0.125, and then the larger gap here, the larger finger, is a little wider to accommodate the nut, and it's 0.25. So let's see, let's do 0.25 first, and I'm just going to pick the line there. 0.25. Alright, so that gives me that. I'll go ahead and I'll pick up the center line of that and then drag it out. Alright, so there's that one. I'll go ahead and delete that line. Alright, now I need 1/8 of an inch for a gap. So again, I'll just do a line, and I'm going to start right there. 0.125. Alright, and then I'm going to go ahead and do another line, 0.125 from the end of that. And I'll go ahead and do my center. Just drag her down. Okay, go ahead and delete out these extra lines. And I just delete out the extra lines to avoid confusion later on. Alright, so I need another, and actually I could just do a line here. 0.125. And then do my center. So there that is. Go ahead and delete that. Alright, so what that did is it gave me the profile for my fingers, my mounting fingers. The geometry, I should say. So I'm going to exit sketch. Go back to features. And I'm going to do extrude. And then I'm going to pick those. And I don't remember how tall those are. 3/4 of an inch. go up here, 0.75, and just go ahead and extrude those. All right, so now we're actually starting to look like something here. Okay, so I will actually do some filleting on those, but before I do that, I'm going to go ahead and I am going to this is the thing I struggle with the most is getting this silly thing so I can get it the way I want it. Alright, so while I still have square geometry, I'm going to fillet this in a minute, but I'm going to go ahead and set up for the hole for this M5 nut. And so first thing I need to know is, and I'm going to look at from corner to corner what's the largest diameter, and it's a little under 0.35, so I'm going to go ahead and make it 0.35. And then I also need to know how far down, and I think that was 1/4 of an inch. Yep, 1/4 of an inch. So let me go ahead and do sketch, pick there. Let's see, I'm going to do a line and do it from there. And about 0.25, enter. Yep. Okay, so that gives me the center line, it gives me the center line and the distance, the offset distance from the top here to the center of the nut. I'm going to go over here and grab my polygon. It's already set up for a 6-sided. Before I do that though, I need to, so 0.35, be half of that is 0.175, right? 35 times 0.5, 1.175, just to make sure. So I just go ahead and from there I'm going to go that doesn't seem right. Hold on. 0.35, 0.175, yeah, okay. 0.175 there, escape. Alright, and I'm going to leave this in place, otherwise I can wind up shifting the location of the hole inadvertently. Alright, so what I'm going to do is just grab there, and I'm going to drag the point of it down to there, and that gives me my geometry for that. Alright, now I also need to make a through hole that goes all the way through this. So I need to go ahead, I can go ahead and set up the geometry for that while I'm here. And I'll just do a circle, pick up the center there, and then it's a 0.1, it's actually a 0.2, 200 thousandths diameter, and so radius on that 0.1, and then poof. Alright, so give me an exit sketch, features, go ahead and do an extruded cut, and we'll cut that, and I'm going to do this through all, click, right, and then I'm also going to do an extruded cut. Dang it. Thing's being silly. Let's go back. Sketch 5. Let's do. This is one of the things that does frustrate me from time to time is it doesn't do what you think it should do. Thickness of the nut is 0.15. It's a little bit deeper than that, so we'll go 0.16. 16. Alright, so that made that cut. And then should be able then to extrude cut. Exit sketch. Okay, here we are back. I'm still not sure what happened there, but yeah, this is one of the things that I thought, you know, that I'm not, that I don't have the confidence level. Sometimes I'll do something silly and just frustrating to figure out how to undo it, or you know, it'll do something like that where it just did not want to go. So anyhow, we're back to it. So now I've got that selected. Instead of blind, we're going to go through all and then cut, and then there we go. We've got a hole all the way through. We've got our space in here for the nut to sit in. Alright, so now the next thing we need to do is we'll go ahead and do the filleting. Let's see. We'll do the filleting here on the top and at the base. So we'll make those nice and rounded. Get your focus back in on that. There we go. Alright, so fillet. Let's see. Let's do the bottom first. I think that I did a 0.25 on that before. Yep, that looks good. Now we'll do the exact same on the tops. It's already defaulted back to what I set for the last time. And there we go. That looks nice. Alright, while we're at it, we can go ahead and fillet these corners. So we'll select fillet. And I think I want to do 0.675 on those, I think. 0.675, make for a nice small round. Nope. About 0.1875. There we go. So it makes for a nice smooth transition there. All right. So we're almost done. So I need to add, go ahead and add this, and that's a 3/8 inch, 0.375 by 0.675, I believe. I don't really remember for sure. We'll measure it here in a moment. All right, so I'm going to go back here, go ahead and go back to my sketch. Yeah, pick a spot there. And the easiest way to pick up the center here is just to draw a line from the center line down. Alright, that gives me a place to center this. Because this is bigger than that platform. That platform is 125 thousandths thick, and the little extrusion there is 0.375. Alright, so draw that because this circle is going to be a little bit bigger. Alright, and I'm just going to grab a circle, go there, and then 0.375 times 0.5, 0.1875. I knew that. I don't know why I had to do that, but whatever. 0.1875. Okay. Alright, going to go ahead and exit sketch. Features, extrude, boss base. And we're going to select all this area. And then, how far did I want to do that? 625. 0.625. Okay. Bingo. Looks good. All right, now we need to add a little bit of filleting here to add some strength to it. So go to my fillet, and then I'm going to go, I think that 0.1875 will actually work there. Nope. What did I use? Maybe it was 100 thousandths. There it went. Okay, so now we've got a nice little fillet there, and then I can use I think I wanted 0.1875 there. There it goes. Yeah. Okay, so it makes for a nice fillet. Add some strength to that. Okay, so we're almost done with this. Going to go ahead and flip it over here. Get it back on a view that's most advantageous to me. Alright, and then so the last thing that I have to do with this is get the, again, from corner to corner, the largest size of this nut, which is about 491 thousandths, and I'm going to give that about 15 or 16 thousandths. So I'm going to do 0.505. So 0.505 times 0.5, 2525. All right, so sketch here, and let's go ahead and do a line. And 0.2525, enter. Escape. Again, that just gives me a reference line, and then I'm going to grab my polygon shape here, and I'm going to drag that far corner down to there. There it is. Hit OK. Exit sketch. Features. We're going to do an extruded cut of this. The thickness of this is about 220 thousandths. I'm going to go a little bit deep. I'm going to go to 225. Maybe I'll do it 230. 0.230, because I want that to actually be fully engulfed. All right, and there it is. So there we have our full part done. So last thing I have to do, I'm going to go ahead and file, save as. All right, let me Stalcher. Alright, so this is GoPro adapter final, and it's Noga tripod and micro tripod. Okay, so I'm saving it as a SolidWorks drawing or a part. Now I'm also going to do, and this is the important part, is I have to save it as an STL. So I'm going to go down here, and so it defaults to .prt, .SolidWorks part, and instead I'm going to come over, I'm going to click STL, which stands for stereolithographic file, and then I'm going to save it as that, and just answer yes to. And you can see what it's doing is it's actually generating toolpath geometry in essence. So there it is. All right, so now what I need to do is I need to take that STL file, come back to me here. Wrong way. So now what I have to do is take that STL file. I use Catalyst 4.4 is the program that we use to control our Uprint, our Stratasys Uprint SE Plus 3D printer. It'll take that STL file. I'll change the orientation of it so that it's most advantageous for printing, and then I will create a .cmb.gz file, which is what what Catalyst uses to actually send to the 3D printer. So we'll do that here in just a second. More to follow. Thanks. Okay, so here we are. We just designed our part in SolidWorks, and we saved it as an STL file. And so now I've opened up Catalyst EX 4.4, and what I'm going to do is I'm going to select File, Open STL, and then we'll find that file. Actually, this is not the same file. This is an older file, but it's fine. So here we have our part, but it's on its side, and while it will print like that, I will get a much better print if I put this flat side down. So what I'm going to do is I'm going to go over and click on orientation, and then I'm going to go X, flip it 90. Yeah, that'll be fine. Alright, so now what I'm going to do is process STL. And so what you see it doing is actually creating the tool paths for the extruder to follow. And there are two different types of tool paths. Our Uprint SE Plus has a dual extruder, and so one head is for the soluble support, and the other is for the model material. And so the model material is the red, and then the white is the soluble support that goes in to help hold everything together so that when it prints, the overhangs don't sag down, essentially. Alright, and so there it is. I'm going to go ahead and go to Pack and just insert the CMB. There it is. Alright, there it is. If I wanted to put another one in there, I could just go ahead and do another one, and I could print as many as I wanted, as long as it'll fit within the work area of the actual printer. And then from that point, I would just go to print. Go. Alright. And so now it sends that information to the printer. The printer is going to do its thing. It's going to go through, and it's going to initialize and make sure that everything is square, and then it will actually start printing. So when I first started this, I really couldn't find a video that showed how we got to the final part, and so hopefully this is helpful to you, and so look forward to comments. Thank you. Alright, so here we go. I turned on the 3D printer. It's actually going through an initialization process at the moment. And so it's going to go through, it's going to do a bunch of checks. The thing about the Stratasys printers is that very high quality. The entire work area is heated. and that reduces warpage of your parts. And so it'll go through this. It's now, it's asking me if I remove the last part. And so, yeah, open the door because I already removed it. Part's been removed. And now it's waiting for me to send the part to it, so I'm going to send it right now. Okay, so just sent that. Go ahead and start model. It's going to warm up, and it takes about 10 minutes for it to actually get up to heat. Okay, so it's finally warmed up. It took about 10 minutes, probably more like 12. What it's going to do now is going to go through a calibration process to make sure that the table is square to the head. I've got a couple nicks in the tape. I think that it'll be fine. It'll be fine as far as the printing area, but when it goes through the calibration process, if it hits one of those, then it won't work, and I'll have to take it out and retape it. If that happens, I'll just cut back to it. So what it's going to do here in just a second is it will just go out and it'll measure the distance from the print head to the plate in several different places. And as I recall, I think it has to be within 12 thousandths. And so I think, well, that's really not a lot, but you know, it's laying down a path of material. It's about 10,000. So if you're off more than that, what you can wind up happening is in some areas it will actually be smearing that that layer. There it goes. Very, very thin. In other places it will be laying a full layer, and so you'll wind up with a part that doesn't actually work. Okay, it looks like it passed calibration. So the next thing it's going to do is it's going to lay down what's called a raft, which is a soluble support, and it will lay down the bottom portion of that. And so once that starts up, I'll bring it back. Okay, so what it's doing right now is it's laying down that raft that I was talking about, and that's just a layer of soluble support that it builds upon. And so it's designed to give it a good adhesion to your printing plate, and then your model material then will adhere directly to the soluble support raft. And so it's going to go back and forth over that a couple of times. It'll actually cross-hatch it here in just a moment and create a solid bedding. And then I'll just bring you back from time to time as it goes through the process so that you get kind of a time lapse of what it's doing. So should do about one more pass, I think, before it starts cross-hatching, maybe. It's going to do a couple more passes. It just keeps building here. This is kind of like the laser cutter kind of measurement. There it goes. There it starts cross-hatching. And so again, it's just building a nice little raft. That's what they call the raft to build a model on. So I'll bring it back periodically as it does its thing, and then we'll throw it in the acid tank and show you the end result. That's all good. So what it's doing when it goes over there into that far corner is it's actually changing out between model material and the soluble support. And so it's clearing the extruder head. And if you can see on the right hand side there's that little bar, and you'll see it here in just a second. It'll go over to the side and bump that bar, which changes the head that it's actually printing off of. So now they go over, they'll clear that extruder head, and then it will come in and it will lay down and I believe that's the model. Yeah, that's the model material. There it goes. Alright, so there we have the completed part. And so just come down here and just pull it off there. Let's see if I can. So you can see the raft of the soluble support. This is what binds to the plate, the printing plate, and then you can see how it formed a support there for the through hole, and then it also built a little bit of a raft to support this because it wasn't actually touching the bottom. And so this will actually go into my tank of soluble support. And come out in an hour or two. Alright, so here we have our tank with the caustic bath to dissolve the soluble support. So I went ahead and I cleaned off most of what I could of it. It just allows the process to go a little bit faster, and it also doesn't bind up as much of the caustic bath. So here we go, we'll set it in here, and then we'll come back here in an hour and it should be ready. Okay, so it's been about an hour, and so this should be ready. And go ahead and pluck this out of here. Looks like everything is good. And there we have it, finished product. Alright, so the last little bit of this is got it out of the acid bath. I've got a 1/4 20 bolt here. It's going to be a nice slide fit, and then I've got my M5 bolt or a nut, and that one's going to be a little tighter. So I'm just going to press that in lightly with a pair of needle nose pliers. Oops, maybe. And then for the bottom one, I'm going to put just a little bit of Gorilla Glue in the bottom of it, just to bond it. And when I say just a little bit, I mean just a little bit. And we'll drop that down in there. That one's a nice snug fit as well. There we go.